Hello everybody. In this video we're going to talk about how you do the 8-1 problems in the pre-cal book. So this is page 516, numbers 4 through 8, 14 to 42, EOE, every other even, 44, 46, 50, 54, 57, and 76. So let's just get started. Number 4 is a true or false question, and it says sine 52 degrees equal cosine 48 degrees. So what you would do, go to your calculator, make sure you're in degree mode. So click right there, and then you do sine 52. So trig sine 52. Or if you didn't switch to degree mode, then remember we could have done the pi button, and then there's the degree symbol. So on your calculator, it would show up as this. And then we do cosine 48, and that gives us a different number. So sine of 52 was 0.788, and cosine of 48 was 0.669. They're not equal. What it should have been is sine 52 equal cosine 38. So this would be false, and it's because 90 minus 52 is 38. So the angles do not add up to 100, they add up to 90 for them to be equal. Our next one is number 5. Again, we have a true-false question. In a right triangle, one of the angles is 90. One angle is 90 degrees. And the sum of the other two is 90 degrees. So this would be true because these are complementary. In a right triangle, one angle is 90 degrees, and the sum of the other two is 90 degrees. That's true, and it's complementary. So in other words, just as an example, say that's a 90 degree angle, and say this is 60 degrees, then this would be 30 degrees. So whatever these other two are have to add up to 90. And then that makes 180 for the entire triangle. Okay, number 6. When you look up at an object, the acute angle from the horizontal to a line of sight, observation is called the angle of elevation. Angle of elevation. And so the key words are up and elevation, and if it were down, it'd be depression. So basically, let's just say there's a person and they're looking from here. So this is your angle of elevation. So the straight horizontal one is the horizontal line, and then I'm saying your object is up here, whether it's a balloon, a plane, or whatever, maybe the top of a building. So that would be your angle of elevation from here to here. Number 7, true or false. In a right triangle, if two sides are known, we can solve the triangle. So, as an example, let's just say you know this is 3 and this is 4, then you can do the Pythagorean theorem, and then you could use trig for the angles. So what I mean by that is you could use this angle would use the opposite and the adjacent. So you'd say tan x equal 4/3. So tan -1 of 4/3 tan -1 4/3, that's 53 degrees. Basically rounded to the whole number. And then I'm going to call this one y, this one z. So then y would be 90 minus 53. So that's 37. So it is possible, if you know two sides, to get everything. So that'd be true. So make sure for that one that you at least have this part of it. If you get everything, it's even better. But we are going to do some examples like this. The reason why we use tangent, it was opposite over adjacent. If you knew these two sides, then you'd have opposite over hypotenuse, so that'd be sine. If you knew these two sides, it would be adjacent over hypotenuse, which would be cosine. And the main thing is you're using your trig for your angles, and it's the inverse, like inverse sine, inverse cosine, or inverse tangent, depending on what you're given. So if you know two sides, then you can solve the triangle. So that's true. Number 8. In a right triangle, if we know two acute angles, so if two acute angles are known, we can solve the triangle. Again, this is a true-false question, and so let's just say we had 53 degrees and 37. Well, now we know all three angles, but we don't know anything about the sides, so this is going to be false. you can't determine the sides. Because even if you do what we did before with knowing these numbers, 37, 53, and 90, it could have been a 3, 4, 5, it could have been a 6, 8, 10, any multiple. And so you can't just say whatever the sides are. Okay, so now to number 14. This one shows the triangle looking like this. And you have 3 here and 4 here. Just as a word of caution, just because you have 3 and 4 in the triangle doesn't mean the other side is 5. Because like in this case, 4 is your hypotenuse. And they have, this is theta. So that's theta. And they want to say find the exact value of the trig functions. So for this one, based on what we're given, we know this is the opposite and this is the hypotenuse. So if we do opposite over hypotenuse, that'd be sine. So we have sine theta equal 3/4. So then theta would be sine -1 of 3/4. So as far as what we need, we have sine theta equal 3/4 cosecant is the inverse of sine, so that'd be 4/3. To do cosine theta, we're going to have to get our adjacent. So in this one, what I need to do is call this vertical line y and do the Pythagorean theorem. Y squared plus 3 squared equal 4 squared. So y squared plus 9 equals 16. Y squared is 7. Y would be plus and minus square root of 7. And because it's a distance, we need to use the positive. So now we have square root of 7 for this length. So because of that, we need to do square root of 7 over 4. Because this is the adjacent over the hypotenuse. And then the reciprocal of cosine is secant. So we have secant theta is 4 over square root of 7. And what they want you to do is rationalize this. And so you get 4 square root of 7 over 7. So these two go together, these two go together, and then we need to do tan and cotan. So tan theta would be the opposite over the adjacent. So that'd be 3 over square root of 7. And again, rationalize that to 3 square root of 7 over 7. And then the cotangent would be square root of 7 over 3. So they basically want you to get used to writing your fractions. A lot of this part is just a review of what we've done before. So we're doing every other even, and so next will be number 18. Okay, number 18, this one shows you the triangle, and it has 2 here, square root of 5 here, and then they're putting theta as that top acute angle. So what we know is this is where the opposite is, this is the hypotenuse, and this is the adjacent. So based on what we know, we have the adjacent over the hypotenuse, and so that's cosine. So cosine theta is 2 over square root of 5, and then you rationalize that like we did before. If you want to skip putting square root of 5 over square root of 5 and just write this, then we can. And then secant theta would be square root of 5 over 2. So those go together. Now for the next part, we've got to figure out what this opposite length is. I'm going to call it x because it's horizontal, and do the Pythagorean theorem. X squared plus 2 squared equal square root of 5 squared. So x squared plus 4 equal 5. So x has to be positive 1, not negative 1. I'm just going to ignore the negative. It is a length, and so it's got to be positive. So now I know this is 1. So for sine theta, this would be the 1 over square root of 5. And so that turns into square root of 5 over 5. And then cosecant would be the reciprocal, so that's square root of 5 over 1, which is just square root of 5. Then for tangent, we know this is the opposite over the adjacent. And so this would be 1 over 2. So that means cotangent would be 2 over 1. On that one, I didn't really write anything extra, so make sure you have all that. The main idea is make sure you do your Pythagorean theorem. Okay, so that's 18. Skip 20, go to 22. On 22, we have cosine 40 degrees over sine 50 degrees. It says don't use a calculator, but what you would need to know is as far as the coterminal, those would work out. So basically cosine of 40 would be the same as sine of 90 minus 40. And so that does work out where they'd be the same. So whatever the number is, it would cancel out, and you get 1. Now, if you'd like to write it a little differently, you can. You could say cosine 40 degrees. That gives us approximately 0.766. And when we do sine 50 degrees, we got the exact same thing. And so this is equal to 1. So the terminology for this is cosine and sine are co-functions. Co-functions. That means they relate to each other. It's not like cosine and secant, because those are reciprocals. These are called cofunctions because cofunctions are complementary. Cofunctions are complementary. Okay, so there's 22. Skip 24, go to 26. And on this one, we have cotan 40 minus sine 50 over sine 40. Okay, so the long way to do this would be, say, cotangent is cosine over sine. And then keep this the same. And then if we know that the cofunction of cosine is sine, then you do 90 minus 40 and you get 50. Then everything ends up canceling and you get 0. So that's the long way to do it. Change cotangent to cosine over sine. Then change this cosine to be sine 50 because those are complementary. The shorter way to do this is just type it in your calculator. Cotangent 40 degrees minus sine 50 degrees over sine 40 degrees. Looks like I have a parentheses mistake, so let me fix that. I need to close it there, and that would work. And so it gives you 0. So 0 is your answer. So these are your steps. Use your quotient, identity, and then use your cofunction. Or the other way was just type it using degrees in degree mode. And so you get 0. So make sure you have this part and make sure you have 0. Whether you work it the long way or just use your calculator. The next one's number 30. Use the right triangle shown. And we have A, B, and C. Those are side lengths, and so all of those are lowercase letters. And what you need to remember is if this is side length A, then the opposite one would be capital A. So these two go together. If this is B, then this one's capital B because they're opposite each other. And if this is C, then this is capital C. So that's what you are going to use for the next several problems. And what you're given for this is B equal 4 capital B is 10 degrees, and it says find A, C, and capital A. Alright, well, the template I usually use is saying A equal, B equals, C equal, A equal, B equals, C equal. That way it's all standard and easy to figure out. So this is 4, this is 10 degrees. We know automatically C is 90 degrees. And so the first step on this would be get capital A, and that'd be 90 minus 10, which is 80. So now we know all three angles. So the next part about this is I'm going to label this as 4. We know this is 80 and this is 10. So B equal 4. So what we're going to do is find A, and we're going to do the opposite over the adjacent. So that's tangent. Tangent 10 degrees equal 4 over A. So we're doing opposite over adjacent, and it's 4 over A. So when your A or any variables on bottom, these two switch places because you multiply by A to both sides, and then you divide by tan 10. So if you just want to go straight from this step to this step, you can. And then we got to find our length. So this is 4 over tan 10 degrees. So I get this. Looks like for this, they want side lengths rounded to 2 decimal places. Round side lengths to the 100th, which means 2 places, and angles to the 10th, which means 1 place. So since the lowercase ones are all the side lengths, we would have 22.685, and because we want to round it, the 5 would make this round up to 22.69. Okay, so for the next part, for C, my recommended approach, since we rounded, is to not just use the Pythagorean theorem, since we rounded. Instead, you just use a different trig function. So in this case, opposite over hypotenuse. So if it's opposite over hypotenuse, then it'd be sine. So sine of 10 degrees equal 4 over C. And so C would be 4 over sine 10. 4 over sine 10. So this gives us 23.035. So that makes it 23.04. So up here I put 23.04. So those are your answers. And here's your work. If you just want to check for estimation, 22.69 squared plus 4 squared in fact, what I'm going to do is I'm going to highlight my previous answer and then say squared plus 4 squared. That gives us 530.6149 whatever, and then take the square root of that, and that gives you your 23.035. So if you use all your decimal places, then it would work with the Pythagorean theorem, but if you round, then it won't. And you'd get frustrated by being off by maybe 1/100th. So I just check with the calculator, and no rounding. Use the values, use the ends. Alright, so there's 30, 34. Okay, so on 34, this one, we use that same triangle. Okay, so here's your triangle with A, B, and C. And on 34, what you're given is B is 6, A is 20 degrees, and it says find A, C, and B. So we know capital C would be 90 automatically. And so in this one, we put our 20 here. This is little a. We put our 6 there. That's also little b. And then little c is there. So to get a first, in this case, this is your reference angle. And so this is your opposite. And this is your adjacent. And this is your hypotenuse. So if we're going to get A first, we're going to do opposite over adjacent because we have a number for the adjacent. So opposite over adjacent, that would be tangent. So tan 20 equal A over 6. Now on this one, your denominator is 6, and so you're going to multiply both sides by 6. So A is 6 times tan 20. Six times tan 20, and this gives us 2.183, and don't really care about the number to the right. This would turn into 2.18. And then for C, we would do adjacent over hypotenuse. So that'd be cosine 20 is 6 over c. Now on this one, our variables on bottom, so you switch places, 6 over cosine 20. Remember, it's basically multiply by c and divide by cosine 20. And so 6 divided by cosine 20, that gives us 6.385, and so we get 6.39. And by the way, I probably should have gotten little b or capital B first. You just do 90 minus 20 to get 70. And so those are your answers. .38. On this one, we have the same triangle. And for 38, we have little c is 10, so we put a 10 there. and we have A is 40 degrees. So automatically we know 90 minus 40 is 50. So all these are degrees. And then to get little a, it's across from capital A, and that'd be opposite over hypotenuse. So that'd be sine 40 equal A over 10. So A would be 10 times sine 40. 10 sine 40. We get 6.427. We don't care about anything after that. And so that'd be 6.43. And then for the B, that's going to be here. So you would use the 40 and you'd use the 10 and the B. You're going to have to use the adjacent over the hypotenuse. So adjacent over hypotenuse is cosine. So cosine 40 is B over 10. So B is 10 cosine 40. Which you get 7.660, so 7.66. By the way, on all of these, if you wanted to, you could check for reasonableness. Like 40 degrees was your smallest angle out of all three, so 6.43 had to be your smallest side out of all three. And your biggest angle was 90, so your biggest side was 10. So that's how you can check your reasonable answers. Our last one for the day is number 42 for this video. And what you're given on 42 is little b is 4. And capital C, or little c is 6. That means little a has to be smaller than 4. Okay, so on this one, if you're given 4 for the B and 6 for this one, I'm going to call this little a. This is an example. If you're given two side lengths, then you do your Pythagorean theorem. A squared plus 4 squared equals 6 squared. And you get 20, which you know is 4 times 5. And so square root of 4 times square root of 5 would be 2 square root of 5. Number 42. So they actually are okay with you rounding. If we just did square root of 20, that's 4.47. You get 4.472, and so just 4.47. And then for your angle, to get A, this would be your adjacent, and this would be your hypotenuse. So that would be cosine. So A would be inverse cosine 4 over 6. And that's 48.189. And so that'd be 48.2 degrees. Now, because we're rounding to the 10th, we probably ought to figure out B by doing adjacent. Well, we could just do 90 minus 48.2, and that's 41.8. If we did it the other way, and you use B as your reference angle, where I put adjacent would actually have to be crossed out and put opposite. And so this would have to be sine -1, 4/6. Sine -1, 4/6. Again, we get 41.81, so 41.8. So those are your answers. The next several are going to be in a different video. Most of the rest of them are word problems. We'll see you next time.